Welcome back to math class. This is Mrs. Witt. This is my Math 7 Accelerated lesson 15.2. We are going to solve using roots. All right, let's begin as we always do by reviewing some important vocabulary. When we are talking about a solution, we're talking about a value that makes the statement true. We know that an inverse operation is kind of like the undo button for the math world. It's kind of like Control-Z. So it's what takes us back to or undoes or is the opposite of whatever operation is listed. An exponent or a power, well, that just indicates the number of copies. That's how many times we multiply the base times itself. Multiply the base times itself by how many ever is listed in the exponent or power, or sometime we might also hear that called the index. Those are all three names for the same thing. So let's just kind of review that really quick. If we look back all the way back to when we were talking about gems and when we do groupings, exponents, well, what is an exponent? An exponent is an index or a power. And again, like I said, it indicates the number of copies that we have when we're multiplying the base. So here it is pink, it is a 3. So that means there are 3 copies of the base. The base is blue, so the base is 4. So you see on the right, the expanded form, it's listed as 4 times 4 times 4. There are 3 copies of 4 being multiplied with each other. Okay, so that kind of gets us all revved up. We're ready to go. We know what we're talking about. So let's remember that if we're going to solve an equation with an inverse operation, we know that that operation undoes the other one. So if we want to undo multiplication, we will divide. If we want to undo division, what do? Well, we go back the other way and we multiply, right? So now let's think about addition. If we want to undo addition, we can subtract. And how do we undo subtraction? Well, we add. So I think we've got a really good handle on that. But let's think about it now. What inverse operation would we use if we wanted to undo a number raised to a power? Because you're not just multiplying randomly, you're multiplying that base. So think about that for just a moment. Let's look at some things. What does being raised to a power, if we wrote that in and out in an extended form, what does that really look like? Well, 2 squared, well, that's a good side note. Let's think about this. When I say the word squared, what am I talking about? When I say the word squared, that means it is raised to the power of 2. And also, when I say the word cubed, we're going to just remember that that means it's raised to the power of 3. Those are pretty standard shortcut words that we use, squared and cubed. So here, 2 squared is the same thing as 2 times 2, which is the same thing as 4. So just looking at that first one, are you getting any kind of intuition about how we would undo a squared? Let's clarify that a little bit, because 2 squared, well, the base is a 2 and so is the exponent a 2. So that might lead us to think some things that might not always work. So let's think about 3 squared. So 3 times 3, which equals 9. Looking at your 3 squared and your 9, think about how we might undo that. The actual inverse operation of raising a number to a power is to find that root of a number. We denote the root with the following symbols. So there it looks kind of like that house thing. So I've got an X underneath there just because we could be talking about any number. Okay, we could be talking about 4 or 9 or 27, whatever. So we're just going to leave a variable in there, x, right now. And what I want you to notice right here is that these first two things mean the same thing. So if I don't see a number tucked in right there, we always assume that it's a 2, okay? So if there's nothing there, or if there is a 2 there, that's talking about the square root. So remember we talked about square, meaning being raised to the power of 2, and cube being raised to the power of 3. Well, it's going to be the same thing when we're talking about the roots. So if there's nothing there, or if there's a 2 there, we assume that is a square root. But now over here, where we've got the 3, so that's a square root. And then over here where we've got the 3, that is considered the cubed root. And what do these words mean? Well, that's telling you to undo those things. So it's the opposite of squaring something, is to take its square, to find its square root. The opposite of cubing something, or taking it times itself 3 times, is to find the cubed root. So let's try this just a little bit. So remember, when we're solving, let's kind of review really quick. What is the goal of solving? Well, to solve something, we want to get one single copy of the variable on one side of the equal sign. So we want one single copy of, in these cases, x on one side of the equal sign, which means everything else would be on the other side. And we're going to use our inverse operations. So let's look at this, and let's start with this first one. X squared equals 4. Well, let's take a minute and say, well, what is 2 squared? Well, that's 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And in our warm-up today, we actually made a chart of from 1 through 9, all of our numbers raised to the first and the second power. You're going to find that useful. So let's, just keeping this in mind, we can look at this and see what the x should be, because it looks just like this first one, right? So we know it's probably going to be a 2, but let's find out here. So I'm going to take, and what I do to the right side, I have to do to the left side. So to cancel out, or to do the inverse, or the opposite of a squared, I need to do a square root. So I'm going to do what I do to one side, I do to the other. Well, I want you to think about it, that this square root right here, it counteracts, or it's the opposite of the squared. So really it's going to get rid of the squared, and it's going to get rid of itself. That's like when we add and subtract at the same time, they go away. Which leaves us with, just on the left side, the only thing left is x. On the right side, the square root of 4. What times itself gives us 4? Well, that's 2 times 2, right? We saw it right over here. 2 times 2 is 4. So that shows us that the square root is 4. Now on the next one, it's a little bit different, because we've got that minus 5 hanging out there, okay? We've got that minus 5 hanging out there, and that tells us, okay, something's a little bit different. What are we going to do? Well, you know when we do GEMS, right? GEMS, when we're setting up everything. Well, when we're solving and we're using inverse operations, right? So this time when we're just performing operations, we use GEMS, right? So operations, when we're using operations, we're going to go through groupings, exponents, multiply or divide, subtract or add. But when we're using inverse operations, which is the opposite, we're going to go back up the other directions. So we're going to start with subtracting and adding, and then we'll multiply or divide, then we'll do the exponents, then we'll do any groupings. So let's look at that. Subtract and add is the very first thing on my list when I'm going in inverse order. So let's undo that minus 5. What I do to one side of the equal side, I have to do to the other. So negative 5 and positive 5, those combine to give me 0. So on the left side, the only thing I have is x squared. And 4 plus 5 is 9. Well, now I have just an x with the squared. There's no multiply or divide, but there is an exponent. So I'm going to have to take the inverse of squared is the square root. What I do to one side, I do to the other. That square root and that squared, they undo each other, leaving me only with x on the left side. And what is the square root of 9? What times itself gives me 9? That is 3. So there you go. Now let's try that with the next one. X cubed gives us 8. Well, again, consult that chart you made in the warm-up. What times itself 3 times gives us 8? Well, to find out, we're going to have to use the cubed root. The cubed root undoes a cube. All right, so the cube root, like I said, that's the opposite of that. That gets rid of it. So the only thing we have left on the left side is x. And on the right side, what times itself gives us 8. Well, that's just 2, right? Because 2 times 2 is 4 times 2 is 8. Yep. Good to go. And with our last example, we're going to notice that same thing where we're thrown for a loop a little bit because we've got that plus 3 there. So we need to go in the inverse of gems. So is there anything to subtract or add left to right? Well, there is. There's that plus 3. So the inverse of plus 3 is to minus 3. What I do to one side, I must do to the other. Okay, so I've still got my x cubed. Nothing happened to that yet. But a positive 3 and a negative 3, those turn into 0. I don't have to write that. And then 11 minus 3, that is 8. Oh, and I've kind of lucked out because here I can remember that I've got something to the cube, to the third power. I need to cube root that to get rid of it. And in the last problem, I was lucky enough to kind of see that the cube root of 8 was 2. So I know that when those two, let's see, that becomes 2. So both of those gave me the same answer that time. All right, now I'm going to give you an opportunity to do a few on your own. Feel free to use that chart that we made in our warm-up. That will get us going. That'll get us helpful. That'll be helpful. And then also, it might be a good idea to start dusting out those calculators. Now is a time when we will start using calculators. Actually, before we move on, I do want to make a quick note, and this is not something we're going to do in this lesson, but it is something that is very important, and we will be talking about it soon. But I want you to be remembering that there is something that we think about when we're taking the square root of something. It could be, we could sometimes see this symbol, okay, which means plus or minus. So the positive or negative. So like if I said positive or negative 2. So let's think about what that means. I'm going to move this over a little bit. Let's see. I'm going to take this very first problem when we said x squared equals 4. And then I took the square root of both sides and I said, well, that turned into x and this turned into 2, which is true. It could be 2. But when I take the square root of something, I have to remember that what if it's the negative 2? So this really says, well, it could be that x is 2, or it could be that x is negative 2. And let's see if that's true. So let's plug in our answers back into the original. So if I had x squared, that means I'd have 2 squared equals 4. Well, that's the same as 2 times 2 equals 4. That's true. But now what if I plug in my negative 2 up there? So if I have negative 2 squared, does that also equal 4? Let's see. Negative 2 times negative 2, it does indeed equal 4. So because we're in that situation when we're squaring something where it could result in a positive and a positive being multiplied together, or a negative and a negative being multiplied together, that's always going to give us that positive result. And we're going to talk more about that in future lessons, but I just didn't want you to be caught off guard if you see this symbol right here that says plus or minus. It means positive or negative. It's actually meaning that there are two options for answers, either the positive form of that term or the negative form of that term. Okay, sorry. Now back to you try, you get this done. Okay, there's a couple things I want to point out. First, I want to point out that we did have, since we had square roots here, we did positive or negative. But you're not going to do that when you have a cube root, because in a cube root, well, for example here, 3. If I have a positive 3, 3 times 3 times 3, well, that's 27. But if I had a negative 3, there's not an even number of negatives there. So that would give me 3 times negative 3 gives me 9. 9 times negative 3, that would change the answer to a negative 27. So when you're dealing with an odd number like a cubed root, then you do have to pay attention to, well, what sign do I really need? And now when I made this final problem over here on the right, I made a mistake. The problem that I had meant to write, x to the third power plus 3 equals 11. But I didn't do that. So I wanted to show you what happens if we don't have our calculator and it doesn't come out nice and pretty. Well, here I went ahead and I added 3 to both sides, and I got x to the third equals 14. And I know that to undo the x to the third, I'd have to take the cube root. So I took the cube root of both sides, which left me just x on the left side. I just have x on the left side. But on the right side, this didn't come out nice and even. That would have given me a hairy-looking decimal that I don't know how to do right off the top of my head. I mean, like, I can estimate where it's going to be, like it'll be between this number and that number. But if, for the sake of this assignment, it's okay to leave it just as that it is the cube root of 14. And look at the directions of each assignment that tells you whether or not it wants you to estimate what numbers it'll be between, or whether it wants you to leave it like this, or whether it wants you to use a calculator and leave a decimal. But if I had done x to the third plus 3 equals 11, what steps would I would have taken? I would have subtracted 3, which would have left me with x to the third equals, actually there it equals 8. And then when I take the cube root of both sides, well, the cube root of x to the third is just x, and the cube root of 8 is 2. So that one gave me a nice, neat, and pretty one. So let's kind of wrap this up. Let's review. How do we solve equations? Well, our goal is to get, the goal is to get one single copy of the variable. Now, a lot of times it's x, but it doesn't have to be. It can be any symbol. And where do we want that? We want that on one side of the equal sign. So when I say we want it on one side of the equal sign, that just means I can't have an x on both sides. I have to have my x just on one side, okay? And once we do that, that helps us determine if we have one answer, no answer, many answers. And if we do have just one answer, what is that answer? And we're going to do that, we're going to use our inverse operations. And what are our inverse operations? Well, let's just list a few. The inverse of adding, we're going to subtract. And that goes back the other way too. If we're going to subtract, if it's telling us to subtract, then we would add. If we're going to multiply, well, that tells us divide. The inverse of divide is to multiply. And if we're going to take something to a power, the inverse of that is to find its root. And the root will be directly related to which power. So if it's raised to the second power, it'll be squared. You look for the square root. If it's raised to the third power, you look for the third root. It would be the same if it was raised to the 100th power, you'd look to the 100th root. And here very shortly, we are going to start getting on our calculators and looking at how do we do that on a calculator. But for today, you should be able to do everything with the chart you made in warm-up. Happy learning.